Okay, question 3 in worksheet A. It's double integral and then they tell you x is between 0, 1 and y. X is between 1, 2 and y is between 0, 1. And they're throwing the letter r. It's because it's a region here. So it doesn't really matter if you do it's a double integral, so you could do it x first and then do y, or you do y first and then do x. I'm gonna do both ways. Pick one of them, it doesn't matter. So, sorry, the question starts like this: no limitations, no limits, like this. So if I decide to do the x first, for example, I write this, then I put dx and the limits for dx, then I put the dy and the limits for dy. That's if I decide to do it x first. Let's do this. So we're doing the integral now with respect to x. The integration of x is x2 over 2. The integration of y, it's a constant, so becomes y of x. I have the two numbers, 1 and 2. I still have the integral dy. So we still need to integrate 0, 1. So this is only for an integral with respect to x, and I'm plugging the 2 points 1 and 2. Put the 2. 2 squared is 4, so that's 4 over 2, and 2y. Put 1, that's half, plus y, and still dy. So your integration from 0 to 1, 4 over 2 is 2, 2 minus half is 3 over 2, 2y minus y is y. So we're integrating this with respect to y. Integral of a constant would be a constant y. An integral of y would be y squared over 2, and you need to plug the 0 and the 1. Plugging the 1 gives you 3 over 2 plus half. Plugging 0 will give you 0 everywhere. 3 over 2 plus half is 4 over 2, that's 2. This is if you decide, so the answer is 2 if we decide to do it dx first. What if we decide to do it dy first? So double integral x plus y, we put dy and the limits for y, 0, 1. And then we put dx and the limit for x, 1, 2. If we find the integral of this with respect to y, a constant would be the constant y, and y is y squared over 2. You need to plug the limits for y and then integrate it in terms of x, 1 to 2. If you put 1 for y, that would be x plus half. If you put 0, it would be 0 and 0. So 0 cancels out. The integral of x is x2 over 2. The integral of half is half x. You put 2 and 1. If you put 2, 2 squared is 4, so that's 4 over 2. Half times 2 is 1. If you put 1 here, that's half. If you put 1 here, that's also half. 2 plus 1 is 3. Half plus half is 1, and 3 minus 1 is 2. So both of them, whether you do it in terms of x or in terms of y first, the answer should be 2. And you don't have to do it both ways. Either do it this way or this way. Question 4 in worksheet A. Integral 01, 02, xy, dx, dy. So they tell you in the question, they want the dx first. A constant x, integral would be 2 over 2, and you need to plug the 0 and the 2. You still have to do the integral with respect to y, 0, 1. Put the 2 for x, that's 4 over 2, so that's 2y minus 0, dy 0, 1. 2y integration is y squared, 0, 1, plug 1 minus 0, 1. Good. So now we can do worksheet B. The first question in worksheet B is similar to the first question we got in worksheet A. You're finding absolute max, absolute min. The function itself and it's on the region x squared over 4 y squared equals 1. First we find the gradient. We find the derivative with respect to x as 2x minus 2. And you find the derivative with respect to y as 2y. You make this equal 0, then y is 0. You make this equal 0, so 2x equals 2, x is 1. So we have a critical point 1 and 0. Step number 2 is you look at the boundaries for the system. So to look at the boundaries, you need to sketch this and figure out how to, or what it looks like. This here is an ellipse. So if I go this way, this is my x, this is my y. The number underneath the x squared is 4, meaning if it's 4, you square root the 4 2. So that means in the x, you're 2 and 2. So this number is 2, and this number is 2. The number underneath the y is 1, and the square root of 1 is 1, so in the y, you're only 1. So in the x, you're 2, and the y is 1, so this here will be your ellipse. So once you have this, the boundaries for the system are, you have this point is a boundary, 2, 0. You have this point is a boundary, 0, 1. This point is a boundary, minus 2, 0. And this point is a boundary, 0, minus 1. So once you do this, you can take everything and plug it back into the original function. So you plug in the 2, 0, the 0, 1, the minus 2, 0, 0, minus 1, and the 1, 0, the critical we found. You plug them all into the original function, which is this, all of them. First one, if you plug them here, 0 is y, 2 squared is 4, minus 4, answer is 0. You plug the 0, 1 here, 0, 0 cancels, 1 squared is 1. You plug the minus 2, 0. Minus 2 squared is 4, 0 cancels, minus 2 and minus 2 is also 4, answer is 8 here. You plug 0 and minus 1. 0 cancels, minus 1 squared is 1. You plug 1, 0. 1, 0 will give you 1 minus 2 minus 1. So in these values, this one is the absolute minimum, and this one is the absolute max. This is the end of part 2. When we come back in part 3, I'll continue with worksheet B.